Find the number of solutions for each equation. If the equation only has one solution, find the solution. So remember, for one solution, the variable does not match. For no solution, the variable matches, but the number piece does not. And for infinite solutions, the variable matches and the number matches. So here, 3x and 6x, those variables do not match. So this is going to have one solution. So you will need to solve it for x. Here, if I distribute, this is 6x, and 6 times -5 is -30. So do the variables match? Do the numbers match? This one, 2 times 4x is 8x, and 2 times 3 is 6. Do the variables match? Do the numbers match? This 5 times x is 5x, and 5 times 3 is 15. Here, the variable pieces do not match, so you will need to solve it for x, because it has one solution. We're going to use the structure of an equation to write examples of stuff that has one solution, infinitely many solutions, or no solutions. So for one solution, the variable term does not match. So it could be like 5x plus 1, and then we need a number here besides 5, like -2x. The constant term or the number term can match or it can be different. It doesn't matter. This piece is irrelevant for the one solution. So we can make it say +1. For infinitely many solutions, everything has to match. So we'll say 5x plus 1 equals 5x plus 1. For no solution, the x term matches, or the variable term matches, but the number has to be different than 1. So we could put a -7 there. Then it would say 5x plus 1 equals 5x minus 7. For this one with the distributive property over here, 2 times 4x is 8x, and 2 times -3 is -6. So we want the variable terms to be different. So it'll say 2 times 4x minus 3 on the left, but the right-hand side needs to be a number that's not 8 in the a's position. So it could be 11x, and then b can be any number. For infinitely many solutions, everything has to match. So we'll keep the left side as it was originally. And then the right side will need to say 8x and -6. For no solution, the variable term matches, but the number term does not. When we look at these, we can see here that the A in front of the variable matches and the number term also matches. So this is infinite solutions. For this one, the variable term matches, but the number term does not, which was a situation with no solution. Down here, we can see that the variable term does not match, and the number term does not match. B and D are not the same. So this is a situation with one solution because the variable term does not match. We're going to write these at the top of our table from the previous slide. So one solution, we'll say AX plus B equals CX plus D. Infinite solutions, the left and right side match. And in no solutions, the variable terms match. But the number terms did not. This one has a B and that one has D. Sean and Logan each find the number of solutions to the equation. Sean's work is shown on the left and Logan's work is shown on the right. Sean says there is only one solution, but Logan says there is no solution. Who is correct? Well, let's check their work as we go. Negative 4 times 5x is negative 20. Negative 4 times negative 2 is positive 8. And on the right-hand side, they have 2x plus 8 plus 8x. 2x plus 8 plus 8x. So in this row, so far, they are both correct. Then they combined 2x and 8x to get 10x. So they are both correct here. Sean subtracts 8 from both sides. You can see here and here. 8 and negative 8 make 0, so we still have the negative 20 on this side. 8 and negative 8 make 0, so we still have the 10x over here. They agreed. Both of them have the same answer so far. Then Sean adds 20x to this side. So negative 20 and positive 20x make 0. 10x and 20x make 30x. Over here, Logan divided by x on both sides. But we don't want to necessarily eliminate the x. We would want to keep the x so we can determine what the solution is. If we go back to this row here, we can see the variable terms do not match. And we know that when the variable terms do not match, it has one solution. So that means that Sean is correct. Now the reason that this doesn't work is because if x was 0, you can't put x in the denominator. If you tried to divide by 0 on your calculator, you would get an error message. We'll learn later why that's the case. When we're talking about slopes, that gives us an undefined slope. And so dividing by 0 is not an option. So since at this point we don't know what x is, we can't divide by it because we're not guaranteed that it's not equal to 0. And you'll see here that it is, in fact, equal to 0. So we can't divide by x unless we are confident, 100% sure that x is not 0. Sometimes they'll provide that information in the situation where it will say x is not equal to 0 up at the top before you start the problem, but in this case it is not. And that's the end of lesson 9. Please check back for lesson 10 shortly.